She is Shashikala, lecturer in physics, SD Government Degree College for Women, Autonomous, Kakinada, Andhra Pradesh. In this video, I would like to explain the types of emissions. Emission of radiation. When the electron jumps from excited state to ground state, that is upper energy level to lower energy level, then the atom emits some energy. That energy is E2 minus E1, that is h nu, energy of the photon. This is called emission of radiation. This emission is of two types. One is spontaneous emission and second one is stimulated emission. First we will discuss about the spontaneous emission. Electron cannot stay in the excited state more than its lifetime, that is 10 power minus 8 seconds. So it takes transition from excited state to ground state 1 on its own by emitting energy h nu. This is called spontaneous emission. That is, without taking the incident energy, the electron jumps from excited state to ground state by its own. So this is called spontaneous emission. So in the figure, observe that atom or electron in the higher energy level E2, it transitions from E2 to E1, then it emits the photon of h nu. So this process is called spontaneous emission. So the number of atoms went from excited state to ground state by spontaneous emission per unit time is NSP. That NSP is directly proportional to number of atoms in the excited state 2, that is N2. So NSP equal to A21 N2, where A21 is the proportionality constant, that is also called Einstein coefficient of spontaneous emission. The suffix 21 represents the transition from state 2 to state 1. Stimulated emission. The second process is the stimulated emission. So the electron in the excited state need not to wait for spontaneous emission. If the excited electron is hit by a photon of energy h nu, then the electron in the excited state goes to the ground state by emitting the energy h nu. So this is called stimulated emission or induced emission. Now observe the figure. Here two photons are of energy h nu are released. One photon is due to the transition of electron and the second photon is the incident photon. Here two photons are of energy h nu are released. One photon is due to the transition of electron and the second photon is the incident photon. These two photons trigger two more excited electrons, giving 4 photons. Observe the figure. The incident photon, first photon, releases the 2 photons and 2 photons absorbed by the electrons, so they will give 4 photons. So this process is continuous. Due to the stimulated emission, the number of photons released increase in geometric progression. If all these photons are monochromatic, coherent and have same direction, then it is called laser, that is light amplification stimulated emission of radiation. The stimulated process, the number of atoms went from the excited state to ground state by stimulated emission per unit time is denoted by NST. That NST is directly proportional to number of atoms in the excited state, that is N2. And NST, that is the number of atoms from excited state to ground state, is directly proportional to the energy density of the radiation, that is rho of nu. So NST equal to B21 N2 rho of nu, where B21 is the proportionality constant. This proportionality constant is also called Einstein coefficient of stimulated emission. The suffix 21 means the transition occurred from excited state to ground state, that is upper energy level to lower energy level, or state 2 to state 1. These are the references that I have followed, and thank you for watching this video.